Welcome to our comprehensive guide on the Splunk Timechart Command. The Timechart Command is one of the most powerful visualization tools in Splunk's search processing language, commonly known as SPL. This command transforms raw timestamp data into meaningful visual representations, allowing you to create time-based charts and graphs with statistical aggregations. Whether you're monitoring system performance, analyzing security events, or tracking business metrics, the Timechart command provides the foundation for understanding trends and patterns in your data over time. Think of it as your gateway to transforming complex log data into clear, actionable insights through compelling visualizations. Understanding the basic syntax of the Timechart command is crucial for effective data visualization. The core structure follows a simple pattern: timechart, followed by optional span parameters, then an aggregation function applied to a field, and optionally a by clause for data splitting. The basic syntax includes three main components. First, the timechart keyword itself. Second, an aggregation function such as count, average, sum, maximum, or minimum applied to a specific field. Third, an optional by clause that allows you to split your data into separate series. For example, timechart count gives you event counts over time, timechart average CPU shows CPU utilization trends, and timechart count by host creates separate time series for each host in your data. Time granularity control is essential when creating meaningful visualizations, and this is where span and bins parameters become invaluable. The span parameter allows you to define fixed time intervals for your data buckets. You can specify spans like 5 minutes, 1 hour, 1 day, or even 1 week depending on your analysis needs. For instance, span equals 5m creates 5-minute intervals, while span equals 1h groups data into hourly buckets. The bins parameter, on the other hand, controls the maximum number of time buckets in your chart. The default value is 100 bins, but you can adjust this to 50 for less granular views or increase it to 200 for more detailed analysis. Understanding these parameters helps you balance data granularity with chart readability. The by clause is a powerful feature that transforms single-series charts into multi-series visualizations. When you add a by clause to your timechart command, Splunk creates separate data series for each unique value in the specified field. This capability is essential for comparative analysis across different dimensions of your data. For example, timechart count by host creates individual time series for each host in your environment, allowing you to compare activity levels across different servers. Similarly, timechart average CPU by server shows CPU trends for each server separately. Remember that the by clause works with only one field at a time, ensuring your visualizations remain clear and interpretable. This splitting functionality enables you to identify patterns, outliers, and trends across different segments of your data simultaneously. Statistical aggregation functions are the mathematical engines that transform raw event data into meaningful metrics for your time series charts. The Timechart command supports a comprehensive range of aggregation functions, each serving different analytical purposes. Basic functions include count for event frequency, sum for totaling numeric values, average for calculating means, maximum for finding peak values, and minimum for identifying lowest points. Advanced functions provide deeper statistical insights. Standard deviation helps identify data variability, median provides central tendency that's less affected by outliers, and percentile functions like perc95 show distribution characteristics. The distinct count function, abbreviated as DC, counts unique values, while range calculates the difference between maximum and minimum values. Choosing the right aggregation function depends on your specific analytical goals and the nature of your data. Real-world applications of the timechart command with span parameters demonstrate its versatility across different monitoring and analysis scenarios. Consider hourly traffic analysis using timechart span equals 1h count to identify peak usage periods throughout the day. For real-time monitoring, timechart span equals 5m average CPU provides granular CPU utilization tracking with 5-minute intervals. Daily performance trends emerge clearly with timechart span equals 1D some bytes, perfect for capacity planning and bandwidth analysis. Memory monitoring becomes effective with timechart span equals 15M maximum MEM, helping identify memory spikes and usage patterns. These practical examples illustrate how different span values serve specific monitoring purposes. Short spans for real-time alerting, medium spans for operational monitoring, and longer spans for trend analysis and strategic planning. Mastering the timechart command requires understanding how to combine its various components effectively. Simple commands form the foundation of time series analysis. Timechart span equals 5M count creates basic event frequency charts with 5-minute granularity. Timechart span equals 1H average CPU shows hourly CPU trends, while timechart count BY host compares activity across different hosts. Timechart maximum memory identifies peak memory usage over time. Complex commands demonstrate advanced analytical capabilities. Timechart span equals 15M average CPU BY host combines time granularity with host-based splitting for detailed performance monitoring. Timechart span equals 1H some bytes BY status analyzes data transfer patterns by HTTP status codes. Timechart span equals 1D perk 95 response tracks daily response time distributions. These examples show how combining span, aggregation functions, and BY clauses creates powerful analytical queries. Effective use of the timechart command relies on following established best practices that ensure accurate analysis and meaningful visualizations. First, choose appropriate span values that match your data granularity and analytical objectives. Too granular spans may create noisy charts, while overly broad spans might hide important patterns. Second, select relevant aggregation functions that align with your metric's nature and your analytical goals. Count functions work well for event frequency, while averages suit continuous metrics like performance indicators. Third, limit your BY clause to a single field to maintain chart clarity and interpretability. Multiple splitting fields can create overly complex visualizations that obscure insights. Fourth, consider your data volume when setting bins parameters to balance detail with performance. The timechart command transforms raw timestamp data into powerful visualizations that enable trend analysis, anomaly detection, and performance monitoring. By mastering its syntax, parameters, and best practices, you unlock Splunk's full potential for time series analysis and data-driven decision-making. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.